We begin our journey on a line that stretches infinitely in both directions. This line is not just a simple drawing, it represents something much more profound. This is the real line, a fundamental concept in mathematics. It is a visual representation of all real numbers, encompassing every possible value you can think of. Imagine all the numbers you know existing on this line, from the smallest to the largest, and everything in between. This includes whole numbers, fractions, and decimals. Every number has its own unique place on this line. Even numbers we can't easily write down, like pi, have a place on this line. These irrational numbers are just as important. The real line is a fundamental concept in mathematics, providing a way to visualize and understand the relationships between numbers. It gives us a way to visualize and understand the relationships between numbers, making abstract concepts more tangible. It helps us see how numbers compare to each other, whether they are close together or far apart. It also helps us see how they relate to each other, showing the intricate connections between different values. The real line is like a ruler that never ends, stretching out infinitely in both directions. It helps us measure distances, represent quantities, and solve problems. This makes it an invaluable tool in both theoretical and practical applications. Whether you are measuring the length of an object or calculating the distance between stars, the real line provides a framework for understanding and working with numbers. It is a bridge between the abstract world of mathematics and the tangible world we live in. The real line is like a map of the numerical world, stretching infinitely in both directions. Let's learn how to navigate it, understanding its structure and significance. 0 sits in the middle of the real line, serving as a crucial reference point. It acts like a central landmark, dividing the line into two distinct halves. To the right of 0, we find all the positive numbers, which increase as we move further right. These numbers are greater than 0, representing values that are more than nothing. As we move to the left of 0, we encounter the negative numbers, which decrease as we go further left. These numbers are less than 0, representing values that are less than nothing. Each number on the real line has a specific place, determined by its value. This place is determined by its value, ensuring a unique position for every number. The further a number is to the right, the larger it is, indicating a higher value. Conversely, the further a number is to the left, the smaller it is, indicating a lower value. The real line is infinitely long. It extends forever in both directions. This means there is no largest or smallest real number. No matter how far we travel along the real line, there will always be more numbers. Another fascinating property of the real line is its density. Between any two distinct real numbers, no matter how close they are, we can always find infinitely many other real numbers. This means there are no gaps or jumps on the real line. It's a continuous and unbroken line. Section 4. Intervals on the real line. We often work with specific sections of the real line called intervals. Intervals help us represent a range of numbers. There are three main types of intervals: open, closed, and half-open. An open interval does not include its endpoints. A closed interval includes both its endpoints. A half-open interval includes one endpoint but not the other. Section 5. Applications of the real line. The real line is not just a theoretical concept, it has countless applications in mathematics and beyond. It serves as a fundamental building block for various mathematical theories and practical applications. Let's explore a few key areas where the real line plays a vital role. These applications span from basic algebra to advanced calculus and even into fields like data science and engineering. The real line is essential for solving inequalities. Inequalities are a fundamental part of algebra, and understanding them is crucial for solving many types of mathematical problems. By representing inequalities on the real line, we can visualize the solution set and understand the range of values that satisfy the given conditions. This visual representation helps in grasping the concept more intuitively. The real line is also the foundation for understanding and visualizing functions. Functions are a core concept in mathematics, and the real line helps us see how they behave. We can plot the input and output of a function on the real line to see how the function behaves. This is crucial for analyzing the properties of functions, such as continuity, limits, and derivatives. In data analysis, the real line is used to represent data points and visualize trends. This is particularly important in statistics and machine learning, where data visualization is key to understanding patterns and making predictions. Scatter plots, line graphs, and histograms all rely on the real line to display data in a meaningful way. These tools help us interpret data and draw conclusions from it. In coordinate geometry, the real line forms the axis of the coordinate plane. This allows us to represent points, lines, and geometric shapes using numerical coordinates, making it easier to solve geometric problems. This allows us to represent points, lines, and geometric shapes using numerical coordinates. Coordinate geometry is essential for fields like physics, engineering, and computer graphics. In summary, the real line is a powerful tool for understanding and working with numbers. Its applications are vast and varied, making it an indispensable part of mathematics. Its properties of infinity, density, and order provide a framework for countless mathematical concepts and applications. These properties make the real line a versatile and robust tool in both theoretical and applied mathematics. From solving equations to visualizing data, the real line is an essential tool for exploring the world around us. Its versatility and wide range of applications make it a cornerstone of mathematical understanding and practical problem solving.